This is Team Interplanetar from Bangladesh University of Engineering and Technology, presenting rover Mongol-E version 2.1. At the very beginning, let's have a look at our team structure, organization and management. The team consists of 11 core members along with a bunch of volunteers and 2 advisors. That is subdivided into 8 sub-teams. Here is a glimpse of our sub-teams. This chart sums up the overall team structure of Interplanetar. The teamwork is classified into 2 categories, that is technical and non-technical. Responsibilities of technical members are to handle electrical and electronic systems, mechanical design and structure, and software and algorithm design. Non-technical section is responsible for management, branding, finance and logistics. Subsection of each section is dealt with dedicated team members. The advisors of our team are Dr. Mohammad Ashikur Rahman, Assistant Professor, Department of Mechanical Engineering, and Dr. Sheikh Anwar Ul-Fatah, Professor, Department of Electrical and Electronic Engineering. The team is managed in such a way that team leaders have regular meet-up with the advisors, and the sub-teams are coordinated according to the direction of team lead. Decisions of every development are taken in weekly meeting. This is the project strategy flowchart we have followed to develop our rover. Now let's have a look at our rover design and its functionality. Version 2 was our first approach for University Rover Challenge 2016, but after further development now we have a more robust one for the upcoming challenge, that is named version 2.1. The mechanical system consists of a body frame, suspension system, wheels and motors, and a manipulator with different end effectors to perform the ascent tasks. The body frame is made of stainless steel fabricated by weldment hollowers, and it has a weight of only 1.7 kilograms. On our previous version, we have a suspension system with differential bevel gear that let our rover to keep the structure balanced while traversing on a rocky and wavy surface. But on our present version, we have a counter linkage mechanism to achieve the desired suspension with reduced weight. Our suspension system also have compression spring as shock absorber. The wheels are of 35 cm in diameter, and the grouses on its surface facilitate our rover with better traction on loose soil. This is the motor we are using in the current version of our rover to drive the wheel. The motor has 3 times more torque than our previous motor that led us to make our rover a 4-wheel drive, having the performance of 6-wheel drive of the previous version. The manipulator of our rover has 6 degrees of freedom and can be occupied with different end effectors. For equipment servicing task, we have a 2-jaw gripper with 4-bar linkage mechanism. For astronaut assistance task, we have a heavy-duty 4-jaw gripper, and for science case task, we have a scooper as end effector. For equipment servicing task, the end effector can be moved in any direction, but for astronaut assistance task, the end effector is always kept vertical for better controlling. We are using both Raspberry Pi and Atmel microcontrollers. All modules are mounted in 2 motherboards that is packed in a removable circuit box. Current feedback from motors adds extra layer of safety. The main controller sends command to slave controllers that drives motors through high current motor controllers. In a similar way, the actuators and other components are driven. Implementation of inverse kinematics improvises the control of the arm. The communication protocols are implemented on a non-metallic shaft to avoid signal distortion. Usage of two separate frequency communication channels eliminates the possibility of interference. Independent control data and video transmission system enables the rover for coherent operations. We are using multi-input system for controlling the rover. 4 computers connected together with personal ad hoc system handles all the data. A total of 4 FPV cameras will be used for the vision purpose. Cameras can be switched from the base station. A dedicated OHD will show the compass and gyro status through the first camera. Along with that, the pH sensor, temperature and moisture sensor, gyro, compass, GPS and current sensors will aid the rover. For powering up the rover, two 10,000 mAh lithium polymer batteries are being used, which is sufficient for making the rover running for almost 45 minutes. Proper safety measure has been taken to avoid short circuit, motor damage and other battery hazards. Let's have a look how our rover is going to perform the competition tasks.